Good afternoon, good evening, everyone. Thank you, Chemtech, for this wonderful opportunity to share our vision for digitization and what's happening around it from AspenTech. As you can see, my topic is more focused towards specialty chemicals. Okay, so what are the key forces, right, which really actually drives the operational excellence today, right? We have been hearing a lot about Industry 4.0, digitization, digital twin, and so on, right? But the key forces, right, which actually what we can say market forces, which really drives your operational excellence are volatility, workforce, sustainability, which you heard a lot about that, as well as the technology or the solutions available today in the industry, right? And you can see some huge dollar values there, right? Which really drives the numbers there, right? So when you say volatility, right, it's really influenced by supply and demand imbalance, right? Energy transitions, right? For example, some factors like macro factors such as tremendous volatility in oil price fluctuation or regional demand variations and so on. So this has a significant impact on operational excellence today, right? Sustainability, right? I think this is all about climate, energy, environment, as well as the social responsibility. We talk a lot about the circular economy, plastic recycling. So it's all about the sustainability, right? So adding new demand, new requirement, and reducing the emission, that actually drives your sustainability. And as you can see, that investment coming in circular economy is almost like 1.5 billion in that range, right? Then about workforce, right? It's about the people, the skill sets, availability, the challenges what we have to train the people and attract the new generation technical workforce today, right? And obviously in this current dynamics, current situation, remote workforce is added another dimension to that workforce challenges, right? And finally about the technology, right? I mean, we talk about the data. We do have a lot of data, but then again, the question is what I'm going to do about that data, how I'm going to make use of that data. So certainly just data is not enough, right? We need a domain expertise. We need people to understand that. We need the new solutions or new technologies built in within that. For example, AI, which I talk about that little later, right? So these are the factors, right, which really actually demand the new levels of operational excellence, right? You will hear some of those in my presentation little later. Okay. Let's look at this value chain diagram, right? So if you look at from left to right, right? So from a broader perspective, right? This is what happens in the industry, right? So when you move from left, which is from upstream, where you get an oil all the way up to the consumer products or what you call CPG, right? What happens is complexity increases from left to right, right? And it drives, of course, the higher value, right? So this is what we call feedstock integration, and companies talk a lot about that, right? For example, you hear a lot about O2C, which is what we call oil to chemicals, right? And that really drives because of the market demand, because fuel demands are going down, or people are looking alternate fuel like green fuel, for example, hydrogen, and so on, right? But when it really comes to high value goods or high value specialty chemicals or consumer products, your complexity increases, right? And that is what companies are really focusing today about how do I really increase the margin when I really optimize the entire value chain from upstream all the way up to the consumer goods, right? And you will hear some case studies or some examples from me later in this presentation about this opportunities available today through this digital technology, what AspenTech offers to our customers to really enhance and optimize the opportunities to maximize the margin. Right? Okay, this looks a little bit complex diagram, but this is what we call the digital solutions available today for across the chemical value chain, right? I won't go all of the details, but some of the things which you can see here, for example, I mentioned about the supply chain, right? So people talking about supply chain integration, a lot of innovations coming into the digital technologies. For example, AI ML coming into the process simulation or process optimization, process analytics. You heard a lot about that. Of course, one of the key drivers in this digitization is predictive and prescriptive maintenance, where companies are looking is early event detection sort of solutions, right? And of course, the other technology like energy management, operator training, simulators, digital twins in the what we call real-time environment, executive management, and so on. But at the same time, what is important from an Aspen point of view, which we're really working towards what we call as a self-optimizing plant, right? And that is something which is the next industry innovation, what we call an industrial AI innovation for the process industry. Right. So let's talk about digital twins, right? I mean, the reason I want to spend some time on this explaining because the digital twin, I mean, there are a lot of definitions one can really talk about that, right? So what really is about the digital twin, right? So digital twin, one can say, okay, it may be a replica of real plant. It could be a process plant simulated into the process simulation platform. It could be a soft sensor kind of things, whatever, right? So you call it is whatever. But when you talk about the digital twin, right, it is very important in today's world, right? Specifically in today's environment, in the context of broader discussion, right, about that digitization or digital technologies, right? It is very important to understand what does really digital twin mean, right? So one can say, okay, today it is very important for a companies to enable the remote work, right? Because it's very difficult for in the current situation people to really visit the plant, right? So how do we enable the remote work? How do I monitor or how do I optimize my equipment performance, right? By sitting at maybe at a remote location or even from a work for environment, how my technologies help me to optimize my plant sitting at the house or sitting at a remote place and looking at the data available today. Asset monitoring, health, or how do I track my health of my asset, right? Then planning or energy consumption, energy optimization, soft sensors, right? Measuring and the reporting the sustainability performance and a few of the things I talked about like emission, right? Because those are the key things one really wants to track and so on, right? So it is a broader thing, right? It's not about the process model. It's not about representing a plant, but looking holistically about the entire plant. Sort of, I am operating it in a remotely, right? So that's how people talk about the digital twin, right? So I'll share a picture here, probably something some of you might have seen that those who are familiar with Aspen technology. So as you look at this picture, right? So there are three parts of that. What you see in a green color, what we call plant digital twin. You see in a blue color, what we call as operational digital twin, and you see a purple color, what we call as is a process equipment digital twin or operational integrity digital twin, right? So there are three parts of that. What it really means is AspenTech really offering a complete digital twin for an asset, not for a process unit, not just for an equipment, right? But we are looking holistically for an entire asset, right? So our view of how company could look at the concept of digital twin, and this will see considerably a broader and more encompassing picture from this diagram, what is projected here, right? So again, just to go back, that blue portion, what we call as operational digital twin, it is mainly about optimizing the operations, right? In the facility, operating assets, as well as planning, scheduling, controlling, execution, distribution, demand management. So all this become part of the operational digital twin, right? When you look at the purple circle, right, it is about the predictive and prescriptive digital twins of the plant, right, where people are looking about the reliability of the equipment or early event detection, right? So those are the things which really we look into, that the operational integrated digital team. And finally, this green word, this is an important part, right? This is what we call plant digital twin, right? And here actually it's important to know the health of the equipment or performance of the equipment, the design of the equipment, when we do sort of revamping of process plant, right? How do I optimize my asset from a both cost perspective as well as from a resource perspective, looking at a capex opex point of view and so on, right? And at the same time, of course, the important here is to optimize the plant in a real-time environment, both from an operations point of view as well as consumption point of view. So for example, if we talk about the energy, right, people always say, okay, my energy is very important, so I should be able to save energy both at operations, that is at my receiver's end, as well as from my supplier's end. So So that's all what we talk about a complete asset digital twin platform, right? And AspenTech probably is the only company who offers this in complete integrated asset optimization for the process industry. Okay. Okay, just moving forward, I will share some of the examples, right? In the previous slide, we talked about the process digital twin, right? And as you can see from this screen, right, one of the example here is the plant digital twin, right? You can see a picture from process simulation, which is, let's say, for example, Aspen Plus process model, wherein we actually simulate the real plant, right? Real plant using the real plant data. One can get the data from data historian on DCS or SCADA from the plant, and connect that data historian to the simulation model, and optimize parameters from the process model. One can actually publish in the dashboard. So here you can see the another picture here where I see what is my current plant performance, what is optimized values, and how much is the gap, and what action I need to be taken here. I should take it here, right? So this is what we call as actionable insights, right? So this really gives an actionable insights to the operators, process engineers, operation people in the plant based on the real-time data as well as based on the first principle models, right? This is a classic example of what we call an operational digital twin model. Okay. This is another example, since I'm talking more about the chemicals today. In chemicals, there are a variety of operations, right? It could be a batch process, it could be a semi-batch or a continuous, as well as there are a lot of solid unit operations like drying, crystallization, so on. So it's a complexity, right? As you heard earlier, I mentioned about when you move from upstream to the chemicals, the complexity increases, right? The process complexity goes up, the reactions, the kinetics, right? The solid handling processes, it becomes more complex and complex, right? But how do you handle that? How do you simulate that? Do you have an accurate properties available? Do you have a data availability, right? Because the convergence, the kinetics, the reaction, it's not the straightforward when we move to the fine chemicals, specialty chemicals, or even pharma ingredients, right? So this actually is handled in one environment in Aspen platforms, right? What we call an is integrated process platform, where you handle the batch processes, continuous as well as semi-batch and solid unit operations in one environment, right? Which really helps to quick and easily simulate batch as well as continuous process in one environment. Convergence become faster, and of course you reduce the dependency on the experimental iterations and so on, right? A lot of examples, I'll share some of them in a while. For example, companies have achieved a significant batch cycle reductions, companies has improved the yield, companies have reduced the energy, quality has been improved, right? So those are the key things what one can achieve really with this kind of solutions, right? This is a broader picture. As you can see, I was talking about the batch and continuous process in one environment, and one can see the properties, right? You can have a 3D diagram or 3D diagram to really track about the properties. Like for example, some applications, right? I want to really study a transition process from batch to continuous, right? How do I do that? Or evaluate the product purifications or solvent recoveries with the different types of solvents or different types of solutions I want to try and test, right? One cannot really do all such experiments in the plant, but this is an environment where one can actually test, try, evaluate it, optimize it, and come up with a solution where actually then I can implement in the plant, right? So this platform helps process engineers or chemical engineers to really optimize the different types of chemical processes, right? And again, as I said earlier, obviously companies have been doing this offline, but now since we're talking more of a digitization and digital twin, this has really become an online now. What it really means that it is a real-time optimizer where it connects the process model, connects to the MES solutions like a data historian, where the models fetch the data from the plant and they run at a defined frequencies to produce the actionable insights for the process engineers or operators. Okay, let's look at some examples, right? And these are the few examples which we choose from chemicals and polymers industry, right? For example, if you look at the example from Dicel, it's a Japanese company. They have been using our integrated digital twin technology, where they have successfully reduced the experiments by 70%, right? For a new polymer grade development, right? Similarly, Hanwha Chemicals from Korea, they increase the production of LDPE by 5 to 7%, and that translated to significant benefits to them, right? Dow Chemical, they have actually, from a safety point of view, they did a site-wide safety studies using this technology, AspenTech digital technology, which actually helped them to evaluate mixing hazards to avoid the accidents and so on, right? Then Mitsui Chemical Japan, they could able to reduce the energy by 1.5%, which is significant, right? 1.5% energy reduction and so on, right? So there are a lot of examples, right? I mean, we can share this with you, and these are sort of what we call as the published case studies or success stories available for us to refer. I mean, how these companies have achieved the significant benefits using this digital technology, right? And the examples are there from bulk chemicals, polymers, specialty chemicals, right, and large petrochemical plants and so on. Okay, now let's move to the next topic. As I said at the beginning, my topic is not just about the digitization. The topic is about the innovations in the digitization, right, for the specialty and chemical industries, right? So let's talk about the innovations, right? So as you can see in the top, right, what we call or AspenTech now call is industrial AI in action, right? So this is something new. This is like what we have innovated, and this is the only unique. This is AspenTech is the only company who has positioned this industry, what we call as industrial AI, into the process simulation. So to elaborate more what it really means, I mean, people are familiar with first principle based models, right? Which is the models based on the equipment and the models based on the first principle thermodynamics, right? And at the same time, we talk a lot about the data today, right? It's about the data science, the data, machine learning, algorithms, and so on. But each of these models, whether it's a first principle or the data, they have their own challenges. For example, in first principle model, it's hard to capture all the phenomena or properties. You certainly need a little bit of expertise there, and also it requires a bit of time to develop the model. At the same time, for the machine learning or data model, obviously you need help of a data scientist, and the most challenging part is the interpretation of the data and so on. So AspenTech, what we have done is we have uniquely positioned this to combine first principle model together with the data model, what we really call it as an hybrid model. So we leverage the domain expertise what we have, combined together with the first principle and AI/ML models, and that combination is what we call as a hybrid model. So these two combined together, we have actually innovated a new modeling methodology, what we call the hybrid model. And you will see some use cases which I'll share in a minute, right? So this is a very unique development innovated by AspenTech. It's already available for our customers to use, and companies are really actually developing a lot of use cases to solve the industry problems using hybrid models. The problems which we could not solve using first principle models, as well as it could not be solved even just with a data model, are certainly addressed with the hybrid models, right? And it is first of its kind AI-based modeling technology available today for the chemical industries. Okay. So hybrid models, right? I talked about that. So it's about the combining your first principle model and bringing your domain expertise and the data into the one environment, right? So it's basically what's about is combining your data and model, including the ability to complex behavior that many cases couldn't be modeled, right? For example, some phenomena or some properties like color or morphology, typically those are very hard to capture into the first principle model, right? But the hybrid model, together with this data model, certainly would help to address those kind of challenges, right? Again, as I said earlier, it is about combining your AI, artificial intelligence, and the data with the first principle model. That what we really bring together to solve this industry challenges of the complex models or the models which are hard to simulate, right? Very specific geometries or that ones which are very proprietary, right? And those could be addressed using this kind of a combination. Okay. Yeah, and I said already, right? The problems that cannot be easily modeled can be addressed or can be modeled here, right? So model which are difficult and complex processes, those are we can simulate here, right? Users, the process engineers can model processes and assets that cannot easily be modeled with first principle alone, right? You get the accuracy of empirical models, the strength of first principle models, leveraging the power of AI with the different algorithms built in here. And of course, as you know, AspenTech has more than 40 years of domain expertise in this area, right? So combining all this together, this is what we call the new innovation, what we have really done into the process simulation or process modeling area, helping our customers, right, to solve any kind of a complex processes, be it a very complex equipment or large asset or whatever you call, helping our companies to achieve increase yield by 1 to 5%, then increase throughput as well as reduce the energy demand. Okay, so that's how companies are really trying to achieve it. Yeah. Now, if you have to look at the sustainability, right, it is also important the model has to be sustainable, right? Because the young generation, the new generation, they are really the technology savvy people, but it is also important that they should have the skills to sustain and maintain the models, right? So AspenTech is ensuring that when the models are developed, it's not just development, it's implemented or it's used in the plant. We also maintain that it is easy to maintain, easy to calibrate, or faster to calibrate at a defined frequency and so on, right? So it is very important for us, right, that we actually develop the model, but at the same time, it is easy to maintain and sustain by auto calibration or by making sure that it is easy to calibrate for the engineers. Okay. Okay, this is another example. As you can see, this is again the example of a hybrid model, right? For example, you see in the diagram, there are different process equipments which are actually simulated using your first principle model. For example, you see the distillation column, pumps, heat exchangers, and so on. But at the same time, we have a model which is actually built into the hybrid environment, what we call a database model, right? So we can actually build into the AI model builder and bring that into the process simulation environment, right? And this combined model, what we call, is a combination of first principle and data model, is actually simulated into the process simulation environment, what we call as a hybrid model, right? So as you can see, you can have reactors, you can have membrane kind of units, or all kinds of complex process equipments which are simulated into the one environment, right? Okay, so let's talk about the example, right? Do we have a real example where this hybrid models? Yeah, of course, we do have a lot of examples. Of course, from a confidential perspective, we may not be able to share the company name, but this is an example from a large petrochemical company in Asia, right? So this is a polymer plant where they have actually deployed this hybrid modeling technology, the first principle combined with the data model, right? Of course, the goal were to reduce the transition time, reduce the waste of polymer grades, and at the same time, reactor model, which they had the LDP, or they have the reactor model, which does not calculate the key properties, right? So the solution is, of course, the standard LDP model, which was developed in Aspen polymers. They actually use this AI-driven model into the same environment, and the benefits, as you can see on the left-hand side, the value created is significant, right? So the 50% grade transition time reduction, which is significant. The savings, almost like $723,000 US per year savings, which is again a significant savings for such a plant. And they also achieved the waste reduction target, basically what they have, the sustainability goals, right? So this is very important, right? So this is one example, but again, if you are interested, please feel to reach us, and we'll be happy to share the use cases or examples relevant to your industry, right? So we can talk, or we can find out what could be the use case where this data-driven and first principle models can be used. Okay. Then next, finally, about the plant digital twin, right? Now here, this is again a classic thing, right, about the plant digital twin, where for example, the column, right? So this is a typical example in any process industry is about the plant digital twin, right? So when a distillation column, right, when we have to do the hydraulic visualization of a column, right? So typically, as you know, in the columns, which are really the key things about the efficiency and some of the hydraulic things in the column, for example, the things like the column flooding, or column weeping or the trays and the packing geometry and things like that, right? So it's very difficult to understand, right? Typically, when you have to do the debottlenecking or turnaround studies and so on, right? But using this AspenTech plant digital twin technologies, one can really quickly do the operation decision support, improve the margins, reduce emissions, and so on. But how it's possible? Because we do have a column hydraulics capability where one can actually see the what's happening inside the column, right? I mean, it's not that I just judge what's inside. It's just not just what just not just what's happening inside the column by looking at the pressure, temperature, flow profile, but one can actually see that in a dashboard, like what's happening in each tray, what is my hydraulic situation, what is my pressure drop, is there any physical constraint in the column, and so on, right? And that really helps to address the any constraints or any challenges for column operations in the plant, right? So this is again a classic thing, and again, when we talk about the plant digital twin for a distillation column, we do handle all sorts of geometry or trays or packings inside the column to really see the very accurate hydraulic hydraulic details of the column. Okay? Yeah. So what are the key benefits, right? I talk a lot about digital twin. I mean, there are two things I talked about. One, digital twin, which are based on first principle based, which is anyway companies are using it now, and the digital twins which are available now, what we call the next generation digital twin, which is based on the hybrid modeling, which is bringing data model together with the first principle model, right? I gave an example of a polymer plant, like a grade transition reduction or the cycle time reduction or reduce the off spec and so on, right? But to summarize, what are the typical benefits? Of course, in chemical plant point of view or spec chem pharma point of view, companies are really trying to optimize the reactor batch time, reduction in cycle time of a process, reduce the impurities, and so on, right? And of course, something like golden batch cycle time. Well, sorry, golden batch selection, right? This is something known word in the polymer industries, if you are familiar with, right? So how do I recognize the golden batch, right? And comparing the runs over the several months, several batches, determine the what are the most optimum operating conditions in the plant, right? The other thing is the soft sensor. This is very important because I cannot really measure all process parameters at all places in the plant. And even if I really depend on the lab analysis, it's a time consuming. It is delayed lab results. And of course, instrument faulty, the errors in the instrument are the again secondary challenges, right? So soft sensors are very important. That's another additional advantage of this process digital twin. And finally is about continuously improving the performance of the plant, right? You can use the dashboard. Those can be customized at a various level, like a dashboard for a management, dashboard for the process engineers, dashboard for the operators, which really gives the insights for the process engineers or operators to take the actions immediately, right? So one really don't have to wait until the problem occurs. You can really take a corrective action even before the problem occurs. So that is the important thing for the spec chem digital twin. Okay? So finally, I would conclude my presentation about AspenTech's vision for sustainability, right? And I talked about that little bit earlier. So sustainability, right? There are really three drivers for that. Specifically, when you talk about chemical industry, right? So sustainability are the three drivers. One is the resource efficiencies, is about utilizing your resource such as energy, water, feedstock, as well as the fuels and so on at a most optimized way, right? Second, and which is most important, which has been talked a lot today, is about energy transition and the decarbonization. You hear a lot about biofuels, alternate energy, green fuel, hydrogen, also about the net zero energy and so on, right? And third is circular economy, right? Here I talked earlier as well. It's about recycling. It's about reducing the plastic waste, right? What are the innovative ways to really minimize the plastic waste or recirculate it, right? And there's a huge market available today, right? And it's like investments going on this in this what we call R&D for circular economy is in the range of 1.5 billion and so on, right? So these are the three key drivers about the sustainability today, right? So if I have to really further look at it, right, of course, the end goal is to reduce emission and the waste. and by achieving this resource efficiencies, the bringing the technologies for circular economy, be it a plastic recycle or renewable feedstock or whatever the way you call it is, and then finally is about energy transition or energy reduction and so on, right? And to track this progress, of course, what we have today, one is really looking into the carbon intensity, harmful emissions like SOx, NOx, safety, renewables, and so on. And what companies are looking, I won't go details, but you'll be hearing a lot of press releases from the companies about their vision for net zero emissions, design out pollution and waste, as well as eliminating the complete toxic substance from their process plants and so on, right? And what is our mission, right? You heard a lot about digital twins, technologies. You heard about the sustainability and so on. But the AspenTech vision is to help our customers in process industry, be it the chemical, energy, upstream, midstream, right, to accelerate the digital transformation, which is anyways part of the today's life of any process industry. So our vision or our mission is to help to accelerate this digital transformation by optimizing their assets, to running it safer, greener, longer, as well as faster, right? So that's our mission for process industries, and we are already there. I talk a lot about new innovations, and you heard some examples, case studies, and we'll be working closely with the process industries to achieving our mission and helping companies to achieve their goals and their vision in the today's environment and today's sustainability world. Okay? So that's all from me, and I'll be happy to take any questions if are there. And thank you once again, Kmword, to giving this opportunity to present on the new innovations for digital technologies for chemicals and specialty chemicals. Yeah?
Thank you. Thank you, Sunil. There is a question
Yeah.
from the audience. To how
Mhm.
much extent does digital twin is similar to the actual working plant, and how do we recognize it?
It's a good question, and I appreciate this question. If I were to really elaborate, right? In other words, in one of the slide I said the digital twin is a replica of a plant, right? So you are creating an image of plant in a platform, in an environment where you can actually run the plant, right? Is like a real plant, right? So what happens in the plant, we really may not able to do a lot of trial runs, or we may not able to play with the plant to do a lot of testing, or maybe like new feedstocks or new catalyst and things like that. But we can really do that into this virtual plant, right? So this digital twin is actually in a layman's language is a virtual plant where we can actually replicate the real plant in a virtual environment, right? And that's what I was referring to. But at the same time, this virtual plant is actually connects to the real plant as well. Meaning, previously people used to do that what we call what if scenario studies, that is offline. Now, since it's a real time connected to the real plant data historian, so whatever is happening in the plant will also happen simultaneously in the virtual plant, so that you can see the immediate effect in the virtual plant, take the corrective action or do the trials, and then the model will predict what could be the way, or what could be the actionable insights for the operators to take the corrective action.